The first three microstructures that we learn, which are pearlite, bainite, and martensite, are the product from austenite cooling or product of cooling austenite. The other two that I mentioned before, which are tempered martensite and sphaerodite, is not formed directly from austenite. Tempered martensite and sphaerodite is an addition in this chapter. It is not directly formed from austenite cooling. For tempered martensite, it is formed from martensite. We change martensite to tempered martensite because martensite is BCT single phase, meanwhile tempered martensite is alpha plus iron carbide, or also known as cementite. For martensite, the properties is hard and brittle, meanwhile for tempered martensite, hard and ductile, and also have toughness. This figure is showing the microstructure for martensite. You can see dark region is martensite needle and white region is ferrite. And then for tempered martensite, where the small particles are the cementite phase and the metric phase is ferrite. The step or process on producing tempered martensite is from austenite. We cool it down immediately until it reaches martensite microstructure, and then immediately after quenching or after the cool it down until martensite microstructure, the sample is heated again about 250 to 650 degrees Celsius. It means that the temperature is lower than eutectoid temperature, which also tells us that the microstructure still maintained in martensite and not changed into austenite. So the martensite is held at that temperature, at this temperature, for about 2 hours. Lastly, remove from the bath and cool in air or at room temperature. Alright. The microstructure produced is tempered martensite. This microstructure consists of extremely small and uniform dispersion cementite particle embedded with a matrix of ferrite. So I repeat again, from austenite we quench it down or supercool until it forms martensite, and then we reheat the martensite up into 250 to 650 degrees Celsius and held at that temperature for about 2 hours. Lastly, we cool it down at room temperature. Okay, I hope it's clear. And lastly, for sphaerodite, just like tempered martensite, sphaerodite also not directly formed from austenite. Sphaerodite is formed from bainite or pearlite. To produce sphaerodite, we can see in this figure, from austenite we change the microstructure to pearlite or bainite, and then we let it soak at that temperature for more than 24 hours or long enough in order for pearlite or bainite change to sphaerodite over here. Okay, this is example for austenite change into pearlite, and then we further let it sit at that temperature until it change into sphaerodite. This is example for austenite change into bainite, and then we let it sit at that temperature until change into sphaerodite. Okay, so for tempered martensite and sphaerodite, it is not directly from austenite. It must change into martensite or pearlite or bainite in order to change to tempered martensite or sphaerodite. Alright, that's all a little bit brief on TTT diagram, product of cooling austenite, and a little bit on properties of the product of cooling austenite. In next video, we will do example on TTT diagram. So till we meet again, thank you, have a nice day.